All right, so the last section of the chapter is, I think, an easier one for what we're going to do anyway. So it's comparing linear, which we did in chapter 4, exponential, which we did in chapter 6, and quadratic, which is what we're doing right now. And so really there's a lot more that we could do with this. We're just going to kind of do the beginning, like part of it. And so we have linear graphs, which linear is a line. So that should kind of make sense. And we have exponential graphs. They're just kind of a curve. They don't turn back and go, if they're up on one side, they're going to be down on the other side. But it's not like a straight line. So it could be like this. It can go in different directions. It's just going to be kind of like flat on one side and either go down or go up on the other side. Okay, and then quadratic is our U, or it could be an upside down U. So literally the first 4 problems are a graph of just points. So they're not connected. And you just basically want to look at like, hey, if I connected these, what kind of graph would it be? Okay, plain and simple. And there's not gonna be a neither like choice. So the answer is linear, exponential, or quadratic. Okay, so just if you can draw a straight line through all the points, linear. If it's gonna look like a U, quadratic. If it's gonna look like a curve, exponential. Okay, then the next set of problems, it gives you a list of coordinates. You're gonna put them on a graph. And when I connect the dots, am I going to get a line? Am I going to get a curve? Am I going to get a U? Okay, linear, exponential, quadratic. So should be pretty straightforward. Okay, then the last ones will be a little bit different. Not hard, but just different. So we have a chart. And it really kind of is similar to just having like coordinates. So let's see, we have 5. So if I had -3, -2, -1, 0, 1, 11, 8, 5, 2, -1. So we really aren't paying attention very much to the x numbers. We're just going to look at the y numbers and we're just going to see what kind of a pattern is going on with the y numbers. And so, is it adding? Is it subtracting? Is it multiplying? Is it dividing? But it just needs to be the same number each time in most cases. So let's look at this one. Is 11 minus 3 is 8. 8 minus 3 is 5. 5 minus 3 is 2. 2 minus 3 is -1. Okay, so it subtracts 3 each time. All right, so adding or subtracting means linear. Okay, so this table, if we put those coordinates on a graph, you'd be able to connect the dots and it would make a line. All right, so again, the x numbers will be there, but we don't need to pay attention to those. So this one, like if I started out, okay, how do I, 1 to 2, it's getting bigger, so that's going to be adding or multiplying. So if I did like plus 1, well, plus 1 doesn't, 2 plus 1 is 3, so it's not plus 1, like that doesn't work. So then it's got to be multiply. So that's 1 times 2, 2 times 2, 4 times 2, 8 times 2. And you notice this one's getting bigger, like a lot faster. It goes from 1 to 16 like pretty quick. So that's also an indication that it's going to be multiply. So if we have multiply or divide, we have an exponential function. Okay, and the book might write it as like instead of divide, like if you were dividing by 3 every time, it might say times 1/3. But remember, fractions mean divide, so it's fine to just say, hey, I'm dividing by 3 like each time, or dividing by 2 or whatever. All right. So then again, the x numbers, they tend to just always go up by 1. All right, so if we looked at these, well, one thing I notice is it goes from -1, it goes to -2, which that means it's getting smaller. But then it goes back to -1, then it goes to 2, then it goes to 7. So it was like, went smaller, and then it got bigger and kept like getting bigger. So if you like look at this, like, well, how do I get, from, so if because it gets bigger or smaller than bigger, it can't be, it's not going to be add, subtract, multiply, divide, like the same number each time. It's impossible for that to happen. So what I do notice is -1 and -2 got smaller by 1, and then this one got bigger by 1, and from -1 to 2 got bigger by 3, got bigger by 5. So there's a pattern. Would you think that like the next one was going to be like bigger by 7, then bigger by 9? Like there's a pattern. It's just not the same number each time. And so how do we like rectify that? Well, if you look at these green numbers from -1 to +1, I go up to again, I go up to again, I go up to again. So if we were to keep looking at like it's what's called a second, pattern, or a second difference. Like what's the difference of the numbers, the green ones? Well, those are the differences. And then the second difference, I have something each time. And so when that happens, so when I have a second difference or pattern, however you want to look at it, that is going to be a quadratic. Okay. It's also like not 100% of the time, but when your numbers get smaller and then get bigger, or they're getting bigger and then they get smaller, that's also an indication that you could have a quadratic. You might have what's called an absolute value graph. The same thing happens on that, but an absolute value graph will not have a second difference. So that's the one difference there. So, but you'll have, I think it's 4 graphs or 4 charts to look at. And again, the answers to every question on the assignment today are either linear, exponential, or quadratic. Okay, so hopefully pretty straightforward for you. All right, so that's it for Friday. First week of back to school done for some of you, and then others another week of virtual, but we're getting closer to the end. All right, have a great weekend, and we'll see you Monday.